Our directions here say find the x-intercept. So if we're looking for an x-intercept, remember y is going to be 0. And so we've got 0 equals x squared plus 6x plus 15. It's a quadratic, so we've learned 4 techniques for solving the quadratics. One is factoring. Quadratic formula is another one. Completing the square, and then taking the square root of both sides, that technique of taking the square root of both sides. So you got to look and see what kind of setup you have. And it looks like to me I'm in standard form. So if I'm in standard form, taking the square root of both sides doesn't work. That technique won't work. So basically that leaves, now I could either factor it, quadratic formula, or completing the square. And this one won't factor. Factor pairs of 15 are 1 and 15, 3 and 5. So there's no way to get a 6 out of that, so it doesn't factor. So now I'm back to choosing quadratic formula or completing the square. Most of you will probably choose quadratic formula, and that usually is my favorite. But I'm going to do completing the square just so we can practice it in case you've forgotten how to do that technique. So in completing the square, first thing I want to do is separate my variables from the constant. So I'm going to move the 15 to the other side. That's x squared plus 6x. And now I'm going to figure out what c is. And then we're going to add that to the other side also. Keep our balance. So half of 6 is 3. 3 squared is 9. So if I add 9 to one side of the equation, I've got to add 9 to the other to keep it balanced. 9 minus 15 is negative 6. And then I'm going to write the other one as a binomial squared. So x squared plus 6x plus 9 factors to x plus 3 quantity squared. Now when I solve that, I'm going to take the square root of both sides, and I'm going to end up with plus or minus the square root of a negative 6 equals x plus 3. So x equals negative 3 plus or minus I root 6. Since this is imaginary and the original question said find the x-intercepts, because I got an imaginary answer for a solution, that tells me there are no x-intercepts. So the answer to this one, no x-intercepts. None. All right, let's try the next one. So once again, I'm looking at this, and y equals a negative 3x squared minus 6x subtract 10. I really like factoring, so first of all, I think I'm going to factor out a negative sign and look at it as a positive leading term for my factoring part. So I'm going to say 3x squared plus 6x plus 10. So will that factor? You've got factor pairs of 3, which are 1 and 3, and factor pairs of 1 and 10 and 2 and 5. Any way to do any combination there to get a 6. I feel like you're going to get a number no matter what you do that's going to be bigger than 6. So this one doesn't factor. So now I'm left with the completing the square technique or quadratic formula. Taking the square root of both sides is not the right setup for this problem. So this time I think I will do quadratic formula. My leading coefficient is a 1, and if it's a 1, completing the square is not too bad. So I think on this one I'll do quadratic formula instead. So we're solving it, so we're going to say 0 for our y. We're looking for x-intercepts. So I've got that equal to 0. I'm going to put this in the quadratic formula, and I'm actually going to use the numbers that I have after I took out the negative sign. So this is going to be A, B, and C. All right, so using the quadratic formula, x equals opposite of b plus or minus b squared minus 4 times a times c divided by 2 times a. So x equals a negative 6 plus or minus the square root of, so we're going to figure out what goes under the radical. So 36 subtract 4 times 3 times 10, and that's a negative 84. Okay, I'm going to stop right there because I'm trying to figure out what the x-intercepts are. And as soon as I see this square root of a negative number, I know that that's imaginary. So I'm not even going to worry about seeing if 84 reduces and trying to reduce the radical and all that stuff. As soon as I know that I have an imaginary answer when I'm solving, I know that there are no x-intercepts again. So this one has no x-intercepts. Okay, let's see what our next problem says. All right, so this one says write the equation for the parabola with the given information. So I know a vertex and I know it passes through the point -2, 5. We need to know what point it passes through because we need to know what kind of an A do we have. Is our A 1? Is our parabola being stretched? Is there a vertical stretch or a vertical shrink? We don't know. All I know is that I have my vertex at -4, 1. So right here, there's my -4, 1. And then -2, 5 is another point on my parabola. So here's -2, 5. And this one is -4, 1. So my parabola is doing something like this. So we need to figure out what the A is. You got to have another point to figure. Just having the vertex is not enough information to help you figure out what the A is. You have to have another point so it will define what kind of stretch you have. But since I know the vertex, I'm going to start out in vertex form. Y equals A times x plus 4 quantity squared plus 1. So that part I know is true because I know the vertex. Now I'm going to use the other point to help me figure out what A is. I need to figure out what the stretching or shrinking in the vertical direction is. So this is a point. It's a solution to what I'm trying to figure out. So this is going to be an x value. -2 is an x value, and 5 is a y value. I'm going to come back to this equation that I'm trying to create, and I'm going to put 5 for y, and I'm put -2 for x. And then I'm going to figure out what the answer is. Well, first of all, this plus 1, I'm going to move it to the other side just so that I don't get mixed up on my order of operations. I'm just going to subtract it over here, and I've got 4 equals A times. Now we need to figure out what's in the parentheses. So -2 plus 4 is 2 raised to the second power. So that's going to be 4. So we get 4 equals 4A. So I know that A is 1. So our equation, our final equation would just be y equals x plus 4 quantity squared plus 1. Okay, let's try it again. So now the information that I give you is the vertex is at 5, 0, and it passes through the point 2, -27. So if you kind of wanted a visual, 5, 0, I'll put 5, 0 right there. 2, -27 is way down here. So maybe this one's going to have a A that really stretches the graph. So maybe our A is going to be greater than 1. And it looks like we're pointing down. So that's also going to help me determine what my A is. That my A, when I'm all done, should probably be a negative number. That's kind of what a sketch of what I think is happening. All right, so let's start out with what we know. We know the vertex, so let's just go ahead and use vertex form. Y equals A, and then x minus 5 quantity squared plus 0. Now, do we really need to write the plus 0? No. So let's just say y equals A times x minus 5 quantity squared. Now, let's use that other point, that 2, -27, to help us figure out what our A is. So remember, the 2 is an x value. The -27 is a y value. So we're going to come over here. We're going to go -27 equals A. Put the 2 in for x. Subtract 5 quantity squared. Now let's figure out what's in the parentheses. So 2 subtract 5 is -3. A -3 raised to the second power is a +9. So this is 9A. And then on the other side, we have a -27. Divide by 9, and you end up with A equals a -3. That makes sense. Before we even started, we knew that our A was going to be a negative number, and it looked like the graph was really being stretched. So having that A value be a 3 kind of gives us a vertical stretch. So our final answer is going to be y equals -3 times x minus 5 quantity squared. That's an equation of the parabola that goes through that given point and has that vertex. Okay, we have two more. So let's see if we can kind of figure out what's happening. So once again, the vertex is 3, 5, and it passes through the point 7, -3. So if I wanted to just make a quick sketch to see what's happening, there's my vertex, 3, 5. 7, -3 would be here. So it looks like to me our graph is going down. So it looks like A is going to be negative. Let's set up what we know. We know the vertex, so I'm going to use vertex form. Y equals A, x subtract 3, quantity squared, plus 5. Now we're going to use that other point that's on our graph right here, this 7, -3, to help us to determine what kind of vertical stretch or shrink we have. It's going to help us find the A. So we're going to substitute in for x, 7, and we're going to substitute in for y, -3. So -3 equals A times 7 minus 3, quantity squared, plus 5. Once again, so I don't mess up my order of operations, I am going to subtract the 5 to the other side. So -8 equals A, and then 7 minus 3 is 4, raised to the second power. So 4 to the second power is 16. So you end up with 16A. Divide by 16, and A turns out to be a -1/2. Okay, that kind of matches what we thought. We thought it would be going down. And let's go ahead and write the final equation. So y equals a -1/2, x subtract 3, quantity squared, plus 5. So there's an equation of that parabola that has a vertex at 3, 5 and passes through the point 7, -3. All right, one last time. So my vertex is -4, -2. Quick sketch just kind of helps me know what's going on. So -4, -2, I'll just put it right here. And it passes through the point 0, 30. So wow, 30 is going to be up here. It's going to be pretty steep, right? So it looks like it's going like this. So it looks like my A is going to be a positive number. Let's set up what we know. We know the vertex, so I'm going to go to vertex form. So y equals A, and then x plus 4, quantity squared, subtract 2. We want to figure out what the A is, so once again, I'm going to put a 0 in for x and a 30 in for y. So 30 equals A times 0 plus 4, quantity squared, subtract 2. So we don't mess up order of operations, add the 2 to the other side. 32 equals A. Now do the parenthesis. 4 raised to the second power is 16. So we end up with 32 equals 16A. Divide by 16. So A turns out to be 2. So we do have a little bit of a vertical stretch there. A is 2. Our final answer is y equals 2 times x plus 4, quantity squared, subtract 2. Okay, I guess we had one more. I thought that last one was the last one, but on this slide there is one more. So our vertex again is at -1, -3. So I'll put it right here, -1, -3. And it passes through the point 1, -1. All right. There we go. I feel like this is kind of a flat graph. I'm thinking that our A is probably going to be a fraction. So let's set it up and see what happens. Y equals A, and then x plus 1, quantity squared, subtract 3. That's our vertex. We are going to substitute in the x and the y, so we end up with -1 equals A, and then 1 plus 1, quantity squared, subtract 3. So we don't mess up the order of operations. Add the 3 to the other side. 2 equals, and then 1 plus 1 is 2, and that's going to be 2 squared. So 2 squared is 4. So you end up with 2 equals 4a. Divide by the 4, so a equals a half. So it did turn out to be a fraction. So our final answer is y equals 1/2 x plus 1 quantity squared subtract 3. Okay, this one down here, it looks like to me I don't have the vertex anymore. It looks like to me I have the x-intercepts. So if I have the x-intercepts, I'm going to need another point besides the 2 given points. If I want to make a quick sketch of what's happening, -2, 0, I'll put right here, 3, 0 right here, and my y-intercept is 0, 12. So it looks like to me my parabola is going to be facing down. So let's go ahead and start it out. Now, because we know the x-intercepts, let's use intercept form. So we're going to say y equals a times x plus 2 and x subtract 3. And we want to know what a is. So once again, we'll put the 0 in for the x and the 12 in for the y. So 12 equals a, and then 0 plus 2 is 2. 0 minus 3 is -3. So 12 equals a -6a. Divide by -6. So a equals 12 divided by -6 is -2. So that looks like that corresponds with our graph. It's a negative number. Our graph is pointing down. So our final answer is going to be y equals -2 times x plus 2 and x subtract 3. That gives us a good equation. We can leave it like that. We don't need to multiply it out. We don't have to. Okay, this one right here is going to be an application problem. So this one says a woodland jumping mouse hops along a parabolic function, and I've created the function there. Now this says x minus 0, so that's going to let you know that you have a x-intercept at 0. Typically you won't see it say x subtract 0. It would look like this. It would say -0.2x and then x minus 6.5. So that x minus 0 is kind of a little hint to let you know that one of the x-intercepts is 0. So what's happening is, here's your little woodland jumping mouse right here, and then he jumps. Okay, we're going to try to figure out how far does the mouse jump, and could the mouse jump over a 2-foot fence? And then we have to explain why. We have to prove mathematically our answer, yes or no. We can't just say yes or no. We got to prove it. All right, so if these are our x-intercepts, then this one right here would be the 0, and this one right here would be 6.5. So anytime we have our x-intercepts and we have a parabola, I know it's symmetric. So I know my axis of symmetry has to go right down the middle. So the axis of symmetry would be 3.25. We would just cut the 6.5 in half, right, to find the middle. We want to know where our middle is. So we just cut that in half. And now what we need to do is figure out what our vertex is. So if I know my vertex, and I have my axis of symmetry, I know my vertex is 3.25, comma, something. Well, to find our something, we come back over here to the original equation, and we plug in 3.25 everywhere we see an x, and we see what we end up for an answer. Okay, so let's just go ahead and type that in our calculator. A -0.2, and then in parentheses 3.25, parentheses 3.25 minus 6.5. And that turns out to be 2.11. There's all the decimal places, 2.1125. Okay, that's our vertex. So it looks like to me we've got some key points. We just need to interpret what do they mean. So the first question says, how far does the mouse jump? Well, remember, the mouse started right here and he jumped to here. So how far did he jump? He jumped 6.5. I'm not sure that I gave units, but I think this is in feet since we're asking if he's going to go over a 2-foot fence. So we're going to say that the units are in feet. So how far did he jump? He jumped 6.5 feet. Now, could the mouse jump over a 2-foot fence? Explain. Well, we know the highest point that the mouse jumped is right here. That's his highest point. That's the max. That's the vertex. How high was that? So do we, excuse me, do we think the mouse could jump over the 2-foot fence? Yeah, because the vertex is 2.11 feet. We can see right here that we calculated the height at 2.1125 feet. So 2.1125 feet is definitely higher than 2 feet. So yes, I think that the mouse could just skim over that fence. So this next slide, if you were in class, I would click on this and you could actually see a woodland jumping mouse and you could make a decision for yourself whether you thought that that was really good data and that the mouse could jump over a 2-foot fence. All right, here's another one. So this one is talking about an osprey, a fish-eating bird of prey, and he dives towards the water to a salmon. The height h in meters of the osprey above water, t seconds after it begins to dive, can be approximated by the function h of t equals 5t squared plus 5t squared subtract 30t plus 45. Determine the time it takes the osprey to reach a height of 20 meters. Okay, so let's kind of get a visual of what's happening. We have this bird up here in the air. So my bird is right here. And down here is the water. And there's this fish down here, this salmon that he's going to get to. So the bird is flying along and he dives down, picks the salmon up, and comes back up. So it kind of makes a parabolic shape right there. And this shape is going to follow this formula. H of t equals 5t squared minus 30t plus 45. So this side right here represents the height after time. That's why it says h of t. And t is going to represent time in seconds. So the question is, determine the time it takes the osprey to reach a height of 20 meters. Okay, well, I'm not really sure how high the bird is starting at, but if I wanted 20 meters, if I wanted to know the time at 20 meters, let's say 20 meters is right here. From the water, 20 meters is that far up. So like this is 20 meters right here. From the fish to the where we're at. So they want to know, so we're going to reach 20 meters on the way down when the bird's diving down and then picks the fish up, and then 20 meters again on when it comes up again. So if that's the height we're looking for, then we're going to put our equation equal to 20. Remember, that's our height after time. So we're going to say 20 equals 5t squared minus 30t plus 45. Okay, I want to combine all my like terms, so I'm going to subtract the 20. So I'm going to have 0 equals 5t squared, subtract 30t, and if I subtract the 20, it's going to give me plus 25. So first thing I notice is that those are all divisible by 5, so I would do that step first, and then I would decide whether I would factor or put it in the quadratic formula. So let's take out the 5, so our GCF of 5. So t squared, subtract 6t plus 5. Now look at that quadratic, t squared minus 6t plus 5. I think that'll factor. So let's go ahead and factor that. We're not going to need to use the quadratic formula. So t minus 5 and t minus 1. Solve it. So t equals 5 seconds or t equals 1 second. So what they're saying is, so the bird is higher than 20 meters. So the bird is up here flying. After 1 second, he's at 20 meters. Time is still going, tick, 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 tick. picks the bird up, tick, 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 gets to here. That took 5 seconds. Now he's at 20 meters again, and then continues to go up again. So that's what that formula said. All right, and then if you were in class, once again, I have another video that you could actually watch an osprey go down and pick a fish up, and you could decide if that really seemed like that was a appropriate problem. Okay, that's it. We're done.